Hello everyone. Today we're gonna start with lecture 5. We covered in lecture 1 through 4. We covered what's assembly language, what's compilation, some of the basic concepts of assembly. We also covered bases. We took base 2, which is binary, base 8, which is octal, base 10, which is decimal, and base 16, which is hexadecimal. And going back to the hexadecimal, why is it important? Why are we learning the hexadecimal base? It's really important it's used in addressing. And if you look now as humans, if we look at a binary number, say 32-bit, it's going to be hard to distinguish it. But if we had it as, let's say for example, 32-bit binary, how many hexadecimal would it be? We say hexadecimal is 16 2 to the power 4. So we group into 4s. So every 4 bits is a hexadecimal digits. So 4 divided by 38, 32 is going to be 8 hexadecimal number. So for example, we had F. It's easy to read than binary. And mostly addresses are in hexadecimal. That's why we have to learn it. It's not used, it's not a computer language, and it's not a human language. So, but we're gonna need it. In lecture 5, we're gonna cover binary arithmetic, adding and subtracting binary, octal arithmetic, and hexadecimal arithmetic. And I think you're all familiar already with, let's say, decimal arithmetic. So first thing, let's start with the binary addition. Binary, we have a couple of cases. What do we have? What are binary numbers? Base 2. We have two numbers, 0 and 1. So we have the case where I have 0 plus 0 equals 0. 1 plus 0 is 1. 0 plus 1, same as this, is 1. And we have the case where I have 1 plus 1. Here I like to consider it as 10, but some people consider it as 2, and we're gonna see how in hexadecimal we consider 8, in octal 8, and hexadecimal 16. But let's see how this goes. I like 10 because we're gonna put a 0 and we're gonna have a carry of 1. Some people like to put it 2. Mouse pointer. So some people like to put it here as 2. So do we have another case? Yeah, we have a case where I have 1 plus 1 plus 1, which is the carry we got, and I considered it as 11. That's why I consider this as 2 and this is as 11. What are we going to consider it? So let's take this example. 1 over 1 is going to cover this case, first case. So it's going to be 10, 0, the result, and 1 is my carry. 1 plus 0, 0, 1. 1 and 1, and here's this will show you that 1 plus 1 is 10 again. I have 0 and 1. Now I'll have the 1, 1, 1 case where I have 11. So I'll have 1 here and 1 here. Now 1 and 1 is going to be 10 again. 1 carry. 1, 1 is going to be 10. 1, 1 is going to be 10. And now I have what? 1, 1, 1. And you have to be careful here. Here is not going to make a difference, but in the octal and hexadecimal you're going to see a big difference. 1 plus 1 plus 1. I have a 1 and an overflow of 1. Overflow of 1. Where does this one go? Is it going to be included in the calculation? No, this is the answer. This is what's stored. This goes to what? We have a register called the flag register, and we're going to take it in chapter 2. This one sets the overflow flag in the flag register, and we'll talk about that later, but keep it in mind, this goes to the register. binary addition, binary subtraction. Same, we have 0 minus 0 is 0. 0 minus 1, we can't do that. We have to borrow, and we'll see how to apply that. 1 minus 0 is 1, and 1 minus 1 is 0. And I'm gonna show you a way where we're not gonna need the subtraction, but anyway, I have to explain it. 10 minus 1, and I'll let you know why we had it 10 here. What's 10? 1 and 1, or 1 and 0. This is 10. So here, what do I have? 1 minus 0 is what? 1. 0 minus 0 is what? 0. 1 minus 1 is 0. Now 0 minus 1. Now in this case, I can't 0 minus 1, so we can't subtract 1 from 0. So we have to borrow. We have to borrow from here. So now this is 0. But how much did I borrow? I didn't borrow 1. Think of it as I borrowed 2 or 10. That's why I had it here, what? 10 minus 1. And there's no 10 minus 0, because if I had 0, 0, it subtracts. So either I consider it as 10 or it's 2. Think if you had, let's say, 69 and 12. Is it? Oh no, this 62 and 19. Let's say 18 or whatever. And we want to subtract this. When I subtract and borrow from here, this is 5. What's this? This is the 10th. This went from 62 when I borrowed, and it became 50 and what? And 12. So I borrowed 10 here. That's why I said 10, consider it, or 2. We borrowed 2 or 10. So 10 minus 1 is 1. Now we have 0 minus 0 is 0. 0 minus 1, we can't. We have to borrow. Can I borrow from this one? No. So we'll borrow from this. So this is 0. What does this become? 2 or 10, consider it. Now I need to borrow from this to this. When I borrow from 10, this is 1, or from 2, it's 1. And this becomes again 2 or 10, whichever one you want to consider it. And so 10 minus 1 is 1, or 2 minus 1 is 1, and we have 0. Let's see, that's the process. This is our result. And if you want to make sure that we got the right answer, what do? Let's do 1, 2, convert it to decimal, subtract it, and see, did it give us the right answer? 16, 32, 64, and 128. So what's this number? This number is going to be 1, 5, 21, and 128. It's going to be 149. I subtract what? 4 and 8, 12, and 32, 44, minus 44. So this should give me what? 105. Let's see. 1 plus what? this is 8, and this is 32 and 64, and that's 96 and 9. It's gonna be what? 105. Right answer. Now we have the octal addition, and we said octal is base 8, so there's no 8 number. So let's try to add. 1 plus 7 is what? Is 8. Do I have 8 octal? No, but consider if I had 9 and 1 in decimal and I added them, it's going to be 0. It's the 10. So 1 and 7. What do I have after the 7? My octal numbers are from 0 to 7. It goes back to the 0, and I have a carry of 1. So this is going to be 0 and 1. 1, 4, 11. Now I have 11. How can I represent 11? If I had it as decimal, I'll put what? 1 and 10. But here, because I have 7, I subtract 7 minus 7. Sorry, oh, that's a long minus. I'll have 4, and this is my 7, the carry or overflow. The carry or overflow. Or should be 11. It should be, no, should be 8. Sorry. 11 minus 8, so it should be 3. Why did I know that? Sorry guys, still 6 a.m. in the morning. I just woke up. This is 8. 8 is 0. So 8 minus 8 is 0, and I have this 8 as overflow. So here I have 11. 11 minus 8 is 3, and here is the 8 and decimal, yeah, right. So now here I have 1 and 2 is 3, and 4 is 7. 7 is an octal number. Here I have 7 and 6 is 13. So do I put 13? No, careful, it's not 13. It's what? 13 minus 8, which is 5. So I'll have 5, and I'll have 1 8. So it's 15. It's not 18. So this is my number. $13. Nope. 30 minus 8 is 5, and I have the 1 left, which is the 8 actually. So this is my octal number. Octal subtraction. What do I have? 1 minus 7. Can I do that? No. So I need to borrow. Can I borrow from this? No. Can I borrow from this? Yes. So this will be 1. How much did I borrow? I borrowed 8. I borrowed 8, which is 1. Be careful. Be careful of this, guys. Look. We borrow 0. We borrow from the 2. I have 1. I borrowed 8. Now I'm gonna do what? I think of it as 10 when we borrow decimal. And 5, 2, let's say 6, and this is decimal. Remember, I have 10 here. I'm left with 9, and I borrowed. Why 10? 10 tenths is 100. Same thing here. So 8, I'll have 7 left. And now what do I have here? Is it 11? No, it's gonna be 8 plus 1. The one I borrowed is 8. because base 8 plus 1, I'll have 9 minus 2 is what? 2. 9 minus 7 is 2. Now I have 7 here. 7 minus 7 is 0. Now 1 minus 4. Can I do that? No, I need to borrow. So this is 6. How much did we borrow? We borrowed 8. 8 plus 1 is what? Is 9. 9 minus 4 is what? 5. And this is my octal number. Now go back to hexadecimal addition. Sorry guys, change that into addition. All those are acceptable. We said always it's a good idea, and this is most common with students. They don't write it. A is 10, B 11, C 12, A, B, C, D is 13, E is 14, and F is 15. And when I say base 16, I have range of numbers 0 to 15, and I have 2 to the power, well, 4 is 16, so I group into 4. So each digit of those is 4 binary digits. So now 9 plus 7 is what? Is 16. Well, 16 is a valid number? No, it's going to be 0 and 1. It's the 10th. Let's say 9 and 7 is 16. It's going to be 16. You can think of it. Minus 16. It's going to be 0, and I have the 1 carry. Now I have F and F. F is 15. 15 and 15 and 1 is 31. Can I put 31 not here? No. I'll subtract what? 16, the one I'm gonna what? Carry here. And what am I left with? 15, which is the F. Now 1 and 8 is 9, and 14 is 23. 23 is what? Is gonna be minus 16. 16 is this one, which is the 10th, think of it. And I'm left with 7. Now I have 1, A is what? 10, that's 11, and B is 11. So I'll have 22 minus 16 equals, and careful, don't put 22. Don't put 22, think it's the end. Now, one of the most common errors, I'll put 6, and this is the one, 16. Or you can put it 6 and this one will work. Let's see. 9 and 7 is 16. This is the 16. I have F and F and F. F plus F, 15 plus 15 plus 1, 31. Minus 16, which is the one I'm gonna what? Carry. So it's gonna be 15, which is F, and a carry of 1. Here's the minus 16. Now here, what do I have? 1, 8, it's gonna be 9, and E is 14, it's gonna be 23. Remember, 23 minus 16, it's gonna be 7 and 1 carry, and this is 22. Don't have it, 22, careful. Hexadecimal subtraction. Let's see the subtraction now. I have what? 7 minus A. 7 minus 10. Can I do that? No, I need to borrow. Do I borrow from this? I can borrow from the 0. I borrow from the 8. So this is 17. How much did I borrow? I borrowed 16. Now I need to borrow another one. So this is left 15, or I can think of it as F. And how much did I borrow? 16. 16 plus 7 is 20. So I'll have here 23 minus a, which is 13, which a is 10 I mean, and minus 23 minus 10 is 13, which is d. So let's see it. Borrow. I can borrow from this. I borrow from the 8. How much did I borrow? 16. Now I borrow again. I have 15 left. 7 plus 16. I borrowed 16. So it's 23. 23 minus a. A is what? 10. 23 minus 10 is 13. 13 is what? D. Now 15f minus f is 0. F minus f is 0. Now 7 minus e. Can I do that? No. E is 14. So I borrow from a, which is 10. So now I have what? 9 left. And I borrowed 16. So I have 23. 23 minus e, which is 14. 23 minus 14 is 9. And then I have 9 minus 5. 7 plus 16 is 23. 23 minus 14, which is this e, is 9. 9 minus 5 is 4. This is the answer. So in this lecture we covered the binary arithmetic, octal arithmetic, and hexadecimal arithmetic. Please guys, don't think you understood it. That's good. Go try 4 or 5 examples on each and see how you do. And now I'm gonna show you how we can do it. The subtract, or let's leave it when we take the 2's complement. I'll show you something. Thank you guys. If you have any questions, please leave it in the comment below. Remember the tournament. If you want to be in the tournament, it's gonna be maybe in 3 weeks, let's say. When I finish, I'll give you a week as a review, open questions. We can open a Google class and post the question there, and questions. It's like an exam, so contest, let's say. And I'm offering $100 for the winner, and basically it's for my students. Thank you.